So this is the Module 6 homework, and what I thought I would do just to um, help everybody out is at least walk through what the strategy would be for each of these questions without actually solving it. Now you could watch the video, certainly. I mean, nothing stops you from doing that. But a lot of these questions all refer to the z-scores. Now what the z-scores do is that um, the z-score itself is 0 at the mean. And what it does is the z-score attempts to find out how much we're deviating from the mean. So what you need is a z-score table. Here, and this is all presuming that we have a normal distribution. If we have a standard normal distribution, what's the probability that the z-score will be less than negative 1.54? So to do that, you're going to have to look up a z-table. There's lots of z-score. Actually, you can even get a z-score calculator here too. I didn't even see that. I'm a little bit old school. Actually, that's kind of useful for a lot of these questions. I mean, you could. So now I'm just at z-table.com. It's pretty useful here. This is my first time kind of using it, but it's pretty useful. I was using it just to get a z-score table. So what these all show, what this z-table shows, is it shows both sides, right? So if the z is 0 here, then what you can imagine is that to the left of that, you would have negative z-scores, as you have in the row right here. Then you have the middle, which is kind of like right here. Then you have to the right. So to the right, the z-scores are going to be greater than 1, or greater than 0, and it's going to go all the way up to 1. And what it's doing here is it's always telling you to the left. So if you want to find something that's greater, then you're going to have to subtract 1 minus that to get the rest of it. So let's go back to this right here. So for mine, I have to find what's the probability of getting a z-score that's less than 1.54. So what you do for these kinds of things is you look for z equals negative 1.5, then 4. So I've got 0.0618. Okay, so with that 0.0618, well, that would basically tell me 0.0618 right there. What we need to do is if we want to find out that's going to be less than it, that would be that area. Go back to this here, 0.0618. Now I'm doing this first one for you just so it kind of helps here. And there we go. So that works you a little bit through at least how to then do how to read a z-table, because then when you get to something like question 2, what you're trying to do here is find a range. The best suggestion I'd have for you for these kinds of things is draw it out. Draw it out where you make kind of a hump, a bell-shaped curve, and you put the middle of that curve where the z-score is 0. To the left of that, you'd be negative. So again, this would be where it's 0. And this would be negative, this would be positive. And so here, if I'm looking for negative 1.7 to 2.18, I'm kind of looking for something that must be around here to something way over here. Okay. Well, what that would mean then is that I need to find each of those values. So to get the negative 1.7. Negative 1.70, I'm guessing here, is 0.0446. Okay, so what you would do is that on your picture, 0.0446. And now the other score that I'm looking for is 2.18. So they get 2.18 is 0.9854. And now what I need to do is find the difference between those two. The difference between those two scores, the 0.9854 and the 0.0446, is going to give me that region right there. I'm going to stop answering these. That way you get still the fun of trying to answer these. So here, if we're given a standard normal distribution, what are the chances that a randomly drawn data point, which in this case is 0.9296, what's the probability that the z-score is going to be less than the 0.9296? So what you need to do for something like that is you need to go to the ZTable and you need to find a 0.9296. About the closest we can get is right here. Sorry, 0.9, that'd be less than 0.9296. .9296. So what I'm looking for here from the z-table, if I'm looking for a z-score that's going to be less than that, what can the c be that gets me the closest to that? You can watch the videos. I think they're actually pretty helpful here. But what you're doing here is you're going to try to find the you need to use a cumulative z-score table to find this. And you need to refer to the z-table to find the value closest to 0.9296. In my case, looks to be about 1.47 approximately. And that gets me pretty darn close. For finding a z that's greater than, now in this case, 1.38, 1.38 is 0.9162. But if I'm looking for it to be greater than that, that would be 100 minus 91.62. So you need to be careful that you're looking at when it's asking for greater than or less than, so that you can shift where you're looking, relatively speaking. These are fun. Okay, so, and these are actually pretty easy to solve too. You could do it the mathematical way, or I guess as I just discovering here on the z-table.com. Looks like you can even do the z-score calculator, which just kind of takes the fun out of it, but looks pretty easy. You could type in the mean, the standard deviation, and the value and calculate. So if I did that here, 2.19 for a mean, 0.59, and the actual score, z-score for 2.89. And it gives me a z-score of 1.18644, whatever. I did mine by hand in this case. I don't know. These are pretty easy. Basically, to find the z-score, you're taking the value that you're at. So in this case, 2.89, subtracting the mean, and in the denominator, you're putting the standard deviation. So in this case, it would be, for me, calculating this 2.89 minus 2.19 over 0.59, and you should get a number similar to that. Similar to this 1.186. Which would be right here. Question 6, same process. Question 7, same process. And by same process, I mean you could go to the z-score calculator and type in these values, or you could just do the math. I did the math where you do the value that we're talking about here, 85, minus the mean, 57, divided by 4, and that gets you your z-score. So 6 and 7 are just like that. Now for 8, we're looking at a bell-shaped distribution. And in that bell-shaped distribution here, we're told that the mean is 38, that the standard deviation is 9. What's the approximate percentage error going to be between 20 and 38? What you're looking at here, the trick to this one is if the standard deviation is 9, 38 is 18 away. Sorry, what's the mean is 38. So if the mean is 38, I'm looking for what's going to be 2 standard deviations less than the mean and the mean. How do I know it's 2 standard deviations less? Because 38 minus 2 times 9, 2 standard deviations, 18. 38 minus 18 is 20. So, if we go to what the 68, 95, 98.7, that would be 1, 2, 3 standard deviations away. So if it's going to be between 20 and 38, we're just looking at the left-hand side of this, right? Because so this would be half of 99.7. Because 99.7 is 3 standard plus or minus 3 standard deviations. If I'm only looking for minus 3 standard deviations, then it should be half of that 99.7, which in this case should be 49.85. What? Are you fucking kidding me? What did I do wrong here? I can't possibly be wrong. I can't possibly be wrong. Let's see what I do wrong. 99.7. Let me make sure. How can that possibly be? Sorry, why am I saying 3? It should be 2 standard deviations. Why did I say 3? It's 2 standard deviations, right? Because it's 9 times 2 is 18. Meaning it should be half of 95, not half of 99.7. Again, this is 1 standard deviation, 2 standard deviations, 3 standard deviations. 95 divided by 2, 47.5. Sorry about that. It's me being sloppy. Again, just to give you an idea here, just trying to show you just a picture here. Here's our mean, 0. I am 2 standard deviations away. So if I'm 2 standard deviations away, Plus or minus 1 standard deviation is 68, 34 and 34. 2 standard deviations away is 95. That would be 13.5 plus 34 plus 34 plus 13.5. But if I'm only looking on this side of it, then it's just 34 plus 13.5, which is 47.5. Now in this question, we're looking at basically men and women and the way in which their z-scores are different. This, again, you should be able to calculate using the z-score calculator to solve this. For question 10, I have normal distribution mean 54.9, standard deviation 6.6. The thing to focus on here is what's less or more, so that you know, when I did just the ZTable, so that you know what side of it you're looking on. Less or more. Let me just give you an example here, just to not make this too difficult for you. If I want to know, if I want to try to answer this one, I'm going to do the, let's do it this way, just since most of you are probably going to do it this way. Mean of 54.9. Standard deviation of 6.6. Less than 66.8. So what I'm trying to do here is find the z-score for that value. So that would be 1.80. Okay. .80 puts me at 0.9641. And what do I want? Less than. So, let's see here. So I'm typing into my calculator 100% minus 96.41%. That gets me 3.59. I think in this case it's not asking for it as a percent. I'm just going to solve this one here. So what I did here is I took 100% minus sorry, 1.9641. Sorry. For less, I can actually just put in the value directly. Hopefully, that's correct. For this here, now you're going to take 1 minus your probability to find that right there. Here, where you're looking for the percentile, you need to find that percentile by looking for that percentile on your z-score table here. So I need to find approximately 79%. Should be about right there. So 0.81. That's going to be my z-score. So what's nice about that, about using the math of this, is now you're just solving for the unknown. So now 0.81 will equal x minus, x being unknown because I'm solving for here, x minus 0 over 1. And there we go. In this one, you should be able to find in the book here. This is just a short answer of, do you understand the way in which things deviate?